Hello everyone, welcome to our third online lab class. And today I will talk about soil organic matter determination, and I hope everybody's safe and well. And in this lab class, I'm suggesting some papers and for reading, and you can find some informations you need to write your handbook of soil analysis. Okay, remember for exam 3 you have to write your handbook. Okay, and so watch this online lab class. This is a short online lab class, and please read the suggested papers. And I think you have a good material to select um, the method to to write your handbook. All right, let's go. Okay, let's start. In this lab class about soil organic matter determination, our objectives basically are to reinforce the importance of soil organic matter. You had the lecture about soil organic matter, the Weinder's lecture, and I'm just reinforcing the importance, the functions of soil organic matter, and for environmental, agronomic, agricultural purpose. All right, and also to show you all the main methods for soil organic matter determination. Okay, let's continue. Okay, guys, to start this lab class, my first question is what is soil organic matter? It's a very interesting question. As you can see here on the right side, you can see something like a soil block, maybe. And you can see soil, you can see some roots, you can see some residues, fresh organic matter, and below this picture you can see a very small soil block. For example, only 2 millimeters. All right, this is a microscope image, and on this image you can see different smaller aggregates. Okay, this is the idea. Okay, a soil block, a soil aggregate is composed by many smaller aggregates. Okay, and we have, for example, macro aggregates bigger than 0.25 millimeters, and we have micro aggregates smaller than 0.25 millimeters. Okay, and this is the idea about the soil aggregation and soil structure development. Okay, the question is, what is soil organic matter? In the soil you can find roots and many soil organic matter fractions, right? And but there is a term known as humus. The humus can be considered a stable form of different organic matter fractions in the soil. A stable form after the composition of different organic matter fractions. Okay, this is the idea, the humus. Okay, and of course, humus and soil organic matter are not synonymous. Okay, and you can consider the humus as a end product of physical and chemical degradation of organic matter. And normally, the soil organic matter is determined using a homogeneous soil sample, air dried and passed through 2 mm sieve. Okay, and however, uh, different soil organic matter fractions can be separated and measured in the organic carbon content. Okay, and when I say the soil organic matter content, basically I'm measuring the soil organic matter or the humus occurring in the soil material and passed through 2 mm sieve. Okay, this is the idea. Okay, my second question for you all. What's the soil organic matter determination important? And the soil organic matter can be considered the most important indicator of soil quality and soil environment and in total environment as well. And since it is related to important process, very important process occur in the soil. For example, the first one, the soil organic matter will influence the cation exchange capacity and mainly for tropical soils. Okay, and the second one, for example, search of nutrients. The soil organic matter will suffer decomposition, and as a result, uh, some some plant nutrients will be available for roots for plants. Okay, another important factor is soil water holding capacity. It's very important. And another important function of soil organic matter is related to soil aggregation and resistance to soil erosion and water infiltration. And the soil organic matter will influence and will contribute to development of soil structure and also soil erosion and soil resistant to compaction uh, and also the retention of soil of some soil pollutants. Okay, as you can see, the soil organic matter plays many environmental functions and controls many soil properties. Okay, it's very important for soils worldwide. This is a very interesting and recent work done in USA and published last year. The authors compare different methods for soil organic matter determination, and one of the finds, of course, the soil organic matter results varied according to the method and locations. However, there is a strong correlation between methods. Okay, it's a very good paper, and I'm recommending for you all. This work was done in 2014 comparing different methods for organic matter determination using soil samples from Brazilian savanna, and you can find here detailed information about different methods, and I strongly recommend for you all. And as you know, the idea for XM3 is you select some methods for each soil analysis we saw in our lab class and describe by yourself in your handbook of soil analysis. Okay, in this paper you can find different methods well described, and as you can see here on the right side there is a strong correlation between different methods for soil organic matter. Okay, Okay, these are some methods for soil organic matter determination. And the first one, the Walkley-Black method and colorimetric method, mass loss on ignition, automated dry combustion, and finally, uh, these are more sophisticated methods, spectroscopic methods. For example, I can determine the soil organic matter using this near equipment. All right. The first one, the Walkley-Black method, can be considered the main method used for soil organic matter determination worldwide. It was proposed in 1934 by Walkley and Black. Walkley and Black are the authors. Okay. And the method 1 and 2, Walkley-Black and colorimetric method, can be considered more non-environmental friendly, right? Since they employed hazard chemicals. For example, the method 1 and 2, we have to use the chromium solution, and it's very dangerous, right? And the method 3, 4, and 5 are more friendly, environmental friendly, right? And now I will talk a little bit about each method. Okay. Okay, this is a summary of Walkley-Black method. Basically, to perform this analysis, you need a potassium dichromate solution. Okay, and in this solution, the form of chromium is oxidized form, chromium 6. And when you put the potassium dichromate solution in your soil sample, what happens? Okay, the soil organic matter will be oxidized. What means? All soil organic compounds will be oxidized to CO2, all right? And at the same time, the chromium 6 will be reduced to chromium 3, okay? In the soil suspension, after reaction, we have some remain chromium 6, and we can quantify the chromium 6 by titration using ferrous ammonium sulfate solution, okay, based on the initial concentration of chromium 6 and the final concentration of chromium 6 in the soil suspension. You can determine the concentration of organic carbon. All right, this is a very simple scan, very simple summary about Walkley-Black method. Okay. Okay, now this is the colorimetric method. As you can see, the colorimetric method is very similar to Walkley-Black method. You need a potassium dichromate solution, and after reaction, the soil organic matter will be oxidized, and the soil organic carbon will be oxidized to CO2, and at the same time the chromium 6 will be reduced to chromium 3. Okay, and the same thing for Walkley-Black method. Okay, basically the difference is now we don't need to quantify the chromium 6, the remaining chromium 6 by titration using ferrous ammonium sulfate. And now, as you can see here, the potassium dichromate solution, without soil, the normal potassium dichromate solution is something like orange, okay? And after reaction with soil, the color of soil suspension will change. Okay, will change according to the soil organic matter content. As you can see here, you have different colors, right? And since the color of soil suspension changes, and there is a correlation between transmittance and soil organic matter content. And, and the transmittance can be measured using a colorimeter. All right, that's it. Okay, guys, this is the mass loss on ignition method. This is a very simple method. Basically, we need the oven and a muffle furnace. Okay, we need an oven dry soil sample at 105 Celsius degree, and after that, put into the muffle furnace, and after 16 hours at 400 Celsius degree, you have the ignited soil samples. Based on the difference between oven dry soil sample and ignited soil sample, you can determine the loss of ignition percent by equation 1. It's very simple. And based on the loss of ignition, you can determine the organic matter content by equation 2. Okay, it's a very simple method, and sometimes it's very well correlated to the other methods. Okay, this is another option for organic matter determination. This is the automated dry combustion method, and there are many automated combustion system equipment available in the market, and known as elemental analyzer. And also we need an oven dry soil sample, and based on the heating of the soil samples, for example, up to 925 Celsius degree, uh, you can measure, for example, carbon, hydrogen, nitrogen, and sulfur, and by different techniques. Okay, this is a very accurate method for soil organic matter and for elemental analysis, for example, carbon, hydrogen, nitrogen, and sulfur. Okay? Okay, finally, the soil organic matter can be measured or estimated by spectroscopy methods, for example, VIS-NIR, visible near infrared reflectance spectrometer, and nowadays uh, the non-environmental friendly methods like a Walkley Black method and colorimetric method have been replaced by spectroscopic methods like VIS-NIR, for instance. You can see here this link. I strongly recommend for you all watch this video. This is a short video about uh, VIS-NIR and combine to PXRF technology. Um, okay, since the soil organic matter and its fractions, the soil organic matter content, the soil organic matter concentration, and its fractions will influence the soil reflectance. As a consequence, you can quantify uh, the organic matter content. Okay, it's a very interesting technology and to and powerful technology to measure this organic matter content. Okay. Okay, everyone, that's enough for today for this lab class about organic matter. And now I'm suggesting for you all a video, an extra video uh, showing the PXRF and Visnir technology, and also I strong recommend two papers about methods of organic matter determination, and also the most important, and based on these papers, um, you can find the information you need to select one method to describe in your handbook. All right, I hope you enjoy again, and take care. Be safe. All right, see you. Bye bye.